In this lecture, we are going to see IPv4 header structure, and you can see over here, this is the IPv4 header, which is actually consists of 6 rows. Row number 1, 2, 3, 4, 5, and 6. So here you can see the sixth row is the variable, or you can say optional field, which is of size 0 to which may be variable size of 0 to 40 bytes. Okay, and about the version field is actually the 4 bit field. This is the version first field, and in the first row you can see over here the version field is of size 4 bits. This is the header length and is of size 4 bits. Type of service is 8 bits. Length of packet is 16 bits. Identification number is 16 bits. This is do not fragment. Okay, this is of size 1 bit. This space is not for any use, and this is NOP option, and this is also of size 1 bit. This is more fragment, MF is more fragment, and it is of size 1 bit. Fragment offset is of size 13 bits. TTL is time to live, which is of size 8 bits. Protocol is also of size 8 bits. Checksum is of size 16 bits. Source IP address is of size 32 bits. Destination IP address is of 32 bits. So you can see over here that except the variable field or optional field, rest all the entries or rest all the fields are in terms of bits only, and the optional field is given in the bytes. Now if you try to calculate the size of every row, you can see this is 4 plus 4 plus 8 plus 16, that is 32 bits, or we can say it is 4 bytes. Similarly, in the second row, the size is 16 plus 1 plus 1 plus 1 plus 13, that is again 32 bits or 4 bytes. The third row is of size 8 plus 8 plus 16, again it is 32 bits, or we can say 4 bytes. Source IP address is of 32 bits, or we can say it is 4 byte. Destination IP address is of 32 bits, or we can say it is 4 byte. And this is the variable optional field, that will be, why it is variable, because the size of optional field may vary. Okay, and this is given in 0 to 40 bytes. Now if you look at here the first 5 rows, then the size would be size of the first, this is the optional field. Okay, optional field को अगर हम 0 माने, मान लीजिए अभी शुरुआत में कोई optional field में कोई entry नहीं है, and the size of optional field is 0, then the size of first 5 rows, you can see 4 plus 4 plus 4 plus 4 plus 4, which is 20 bytes. Okay, so here you can see, if you try to calculate the header size would be 20 bytes, and that is the size, which is the minimum size of header, which is of 20 bytes, and that can be calculated, that is 20 bytes, that is fixed, that will be always there. Okay, minimum इतना तो होगा ही होगा, 20 byte तो होगा ही, because these fields first 5 rows are mandatory for every IPv4 header, while the sixth row you can see it is the optional part. And to calculate the minimum header size, we can put the size of optional field as 0 byte, and that will give you in total 20 bytes. and if you try to calculate the maximum header size, that would be 60 bytes, and that is nothing but 20 bytes the fixed size plus variable size of to 40 bytes, that will give you 60 bytes. So that is the maximum of header size. Now if we look at every field one by one, so let us start with the version field. So version, as you know, that version is of 4 bits field only. Version basically it stores the version of the IP header. You can see over here that we are talking about IPv4 over here. Okay, so every IP header have the information of version, so that the processing should know, or you can say the network layer should know कि उस IP header को कोई किस फंक्शन के पास भेजना है। ओके, कहने का मतलब ये है कि अगर हम वर्जन्स की बात करें तो आईपी के आपके वर्जन वर्जन V1 V2 V3 V4 V5 एंड V6। सो इस तरह से अभी तक 6 वर्जन आपके आए हैं, जिसमें से मोस्ट पॉपुलर वर्जन इज V4 एंड नाउ वी आर स्विचिंग टू V6। सो बाकी के आपके वर्जन्स जो हैं वो these are you can say these are less popular, or initially we started with the version 1 and later on as per the modification is done in the version IP version, these 6 versions are being made. So for IPv4 we have to first know कि जो आपका हेडर है वो कौन सी वर्जन को फॉलो कर रहा है, वो IPv4 है या IPv6 है, उसके बारे में आपकी इंफॉर्मेशन किस में स्टोर होती है, कौन से फील्ड में स्टोर होती है, दैट इज द वर्जन फील्ड। सो 4 बिट्स आपकी यहाँ पे हैं जो कि आपके वर्जन्स को स्टोर करने के लिए है। सो अगर हमें V4 के लिए स्टोर करना है, सो IPv4 वुड बी नथिंग बट 0100। अगर IPv6 की बात करें तो दैट वुड बी 0110। सो इस तरह से आपको एंट्री यहाँ पे मिलेगी, 4 बिट्स की एंट्री। ओके, that will tell you the version. Okay, so this is the binary notation of 4, you can see, and this is the binary notation of 6. So by looking at these values, the network layer get to know the network layer basically entry put entry in the IP header कि कौन सा वर्जन वो फॉलो कर रहा है। Okay, now the second field is header length field, and you can see that header length field is also of 4 bits. Okay, now with the help of 4 bit you can you may get to know that we can store 0 to maximum of 15 numbers. Okay, but you can see here that the minimum header size is 20 bytes and maximum header size is 60 byte, but we can store in the header length, we can store maximum up to 15. That means we have to put some scaling factor so that the actual header length can be calculated. So the actual header length or header size will be calculated by multiplying this header length field with a factor of 4, that is nothing but a scaling factor. How we have calculated this 4 over here, scaling factor 4 क्यों है यहाँ पे, you can see that the maximum header size is 60 bytes. Okay, and if we want to calculate the value of 60 within the limitation of 0 to 15, then we can have, if we divide 60 by 15, we will have this 4. So that means मान लीजिए अगर आपकी हेडर लेंथ की वैल्यू 5 है, ओके, सो इफ यू मल्टीप्लाई इट बाय 4 that will give you 5 into 4 is 20. That means the actual header length is 20 bytes. If the header length value over here is 15, then if you multiply by 4 that will give you 60 bytes. Okay, so this is how you can calculate the actual header length by multiplying with a scaling factor, and that scaling factor is 4. यहाँ पे आप ये देखेंगे कि अ, कैसे डिफरेंशिएट करें। मान लीजिए किसी न्यूमेरिकल में या क्वेश्चन में अगर आपको गिवन है हेडर लेंथ, आपको ये गिवन है या आपको एक्चुअल हेडर लेंथ गिवन है, सो यू कैन सी दैट द दिस फील्ड हेडर लेंथ फील्ड की वैल्यू जो है वो 0 से 15 के बीच में होती है, ओके, और एक्चुअल हेडर लेंथ है वो जो होगा आपका 20 से 60 के बीच में कोई ना कोई वैल्यू रखेगा। सो एक्चुअल हेडर लेंथ आपका 20 से 60 के बीच में रहने वाला होगा। वाइल एच ई एल फील्ड की अगर वैल्यू दी गई होगी तो वो आपकी रादर 0 to 15, फॉर मिनिमम 20 वी हैव टू पुट द मिनिमम वैल्यू ऑफ एच ई एल वुड बी 5। सो 5 to 15 अगर वैल्यू आपके पास गिवन दी गई है, सो दैट मीन्स इन द न्यूमेरिकल it has given the header length field value, okay, but if the value of header length is given something in between 20 to 60, that means you will assume that the actual header length is given, okay, then there is no need to multiply it by 4. But if the header length field value is given, then you have to multiply it by 4 to calculate the actual header length. Okay, so next field is the type of service. Here in the type of service, basically you can see there are two bits, one bits are reserved for a special purpose, and the type of service is given 6 bit. So out of this 8 bit, one bit is given for a special purpose, and rest are 6 bits. So 6 bit में हम देखते हैं कि बाकी क्या वैल्यूज आपकी आती हैं। सो इन एक्चुअल आपका टाइप ऑफ सर्विस जो है वो 6 बिट्स का होने वाला होगा, ठीक है। आउट ऑफ 8 बिट 2 बिट्स आर रिजर्व। हेयर 3 बिट्स are given for preference or precedence, that indicates the priority of packet. Okay, and these 3 bits the rest of 3 bits you can see are previously these 3 bits currently these 3 bits are used for differentiated services. So in total, out of these 6 bits, 3 bits are for precedence and 3 bits are used for differentiated services. And previously, this is something currently we use, these 3 bits for differentiated services. Previously, it was something like these 3 bits were used for D, T, and R. D stands for delay, T stands for throughput, and R stands for reliability. Okay, so let's say if source want service like that, let us say, let us assume the source want the services like high throughput, low delay, and low reliability. And that is for, let's say, whenever the source is using any audio video conferencing. And for audio video conferencing, these kind of settings the source actually want. And if for this kind of setting, the value of d would be given as 1, that is low delay. For high delay, the d value is equal to 0. And for throughput, we need high throughput, so the value is 1 high throughput. And R tends to be 0 for low reliability. So basically, previously these 3 bits were used for such kind of services. If a particular user or particular source, if he wants something like this kind of service, so accordingly the value of DTR is going to be set. Now there is no use of this field. Now they will use differentiated services. So this is something I just told you for knowledge purpose, that previously it was used something DTR, and now nowadays we use these 3 bit are used for differentiated services. As far as the rest of 3 bits are concerned, which are for precedence, and you may know that with the help of 3 bits we can have 0 to 7 values. Okay, so 0 will be given to the packet of lowest priority, and if the value is given as 7, that means the packet is of highest priority. Okay, so that is what something is given in the type of services part. And the rest to field, one bit are given over here, are keep left over here. Next is your length of packet. So next field is length of packet. लेंथ ऑफ पैकेट के बारे में हम थोड़ा डिटेल में बात करेंगे, यू नो, in the fragmentation part also. But for now, you can see that length of packet, the size is given, 16 bits are reserved for length of packet, and with the help of 16 bits you can have the value 2 raised to power 16, and that would be equal to 65535. Okay, so that means the length of packet, or the total packet size, if we talk about, so total packet का जो size आपका है, that is your header size plus your data is maximum size can be possible, and that size would be 65535. Okay, so let's say this is a packet, IP packet है. Okay, so this field will show you the size of the packet. Okay, so जितना भी आपका पैकेट का साइज कह लीजिए या लेंथ कह लीजिए. ओके, सो उस कंप्लीट पैकेट का साइज आपका यहाँ पे जो है ये फील्ड आपका बताता है. So maximum size that can be possible over here is 65535. Here you can see this complete size of packet includes the size of IP header and also the size of data. Here you can see this IP header length we have already calculated, that is minimum of 20 bytes and maximum of 60 bytes, and rest part is your data part. ओके इसके बारे में और डिटेल में हम बात करेंगे इन टर्म जब हम फ्रेगमेंटेशन को थोड़ा सा डिस्कस करेंगे. ओके so let us coming to the next field, and that is identification. So identification number is the field in the second row so identification number is given to every datagram to uniquely identify. Okay, so it is a 16-bit number. That means it may have a range from 0 to 2 raised to power 16. Okay, so it is going to use for the fragmentation also. Okay, in fact it is very much useful for the fragmentation. First of all, whenever from a host, whenever a datagram is released, that is given a identification number, and that identification is number is a unique identification number to differentiate the datagram from each other. Okay, so number one is to differentiate the datagram between to differentiate datagrams, and secondly, this identification number is majorly used in the fragmentation. So in fragmentation, basically when a datagram is divided into many fragments, then all the fragments from that datagram are going to have the same identification number. कहने का मतलब यह है कि फ्रेगमेंट्स जो कि सेम पैकेट को बिलोंग करते हैं या सेम डेटाग्राम को बिलोंग करते हैं, उनका सबका आइडेंटिफिकेशन नंबर आपका सेम होगा. For example, if the datagram, let's say this is the datagram, okay, and it has the identification number id is equal to 0, and if we divide into different fragments, then all the fragments have the identification number is equal to 0. Okay, so this is something we have we use the identification number for the fragmentation. Later on when we will discuss the fragmentation, then we will talk more about the identification number. Okay, बेसिकली इसका यूज़ इस तरीके से है, इसको क्यों उनको आपका सेम आइडेंटिफिकेशन नंबर दिया जाता है. सो आप इसको समझ सकते हैं कि यहाँ पे द डेटाग्राम सर्विस जो है आपकी डेटाग्राम सर्विस में आपके पास पैकेट्स जो हैं या जो आपके पास जो फ्रेगमेंट्स हैं वो डिफरेंट पाथ को फॉलो कर सकते हैं. लेट्स से दीज आर द राउटर्स and this is the source. One fragment one packet is one packet or one datagram is being sent to the network, and further let's say at this router it is being divided into number of fragments. So it may be possible that one fragment is going to have this path, and then second fragment is going to have this path, and later it may be possible then if there are other routers, so the third fragment may have the other path, and finally when they are going to reach to the destination, so just by looking at the identification number, the same identification number, the receiver will get to know that all of these fragments belong to the same datagram, and receiver end पे उसको combine करना उसके लिए आसान हो जाता है. ओके, सो इसके लिए बेसिकली इस पर्पज़ के लिए आपका ये आइडेंटिफिकेशन नंबर यूज़ किया जाता है फ्रेगमेंट में. देर आर अदर फील्ड्स which are don't fragment and more fragment. More fragment is again used in the fragmentation that means that actually tells how many fragments are following a particular fragment. Okay, so that means let's say we have a sequence of fragments. मान लीजिए एक ही डेटाग्राम के ये डिफरेंट डिफरेंट फ्रेगमेंट्स हैं जिनका आईडी आपका सेम होगा, लेट्स से आईडी इज इक्वल टू 0. So let's say this is first fragment, this is second fragment, this is third fragment. So the first fragment में जो आपकी mf की वैल्यू होगी, वो mf की वैल्यू आपकी क्या है? It will tell there are more fragments are coming. So mf value will be equal to set will be equal to 1. That is when mf is true, that means the receiver will get to know there are more fragments are coming. Okay, and similarly there are further more fragments are coming, so mf value for this fragment is also will set to 1. Okay, that is true. And for the last fragment the mf is going to be 0. Okay, so the mf is going to 0 will tell that there are no more fragments are coming or no more fragments are following the following in this sequence. Okay, so that is what the more fragment field is. Now we'll talk about the don't fragment field. Don't fragment is something to tell the router. A user will explicitly tell the router that do not fragment this packet or do not fragment this datagram, because he wants the either the whole packet. Okay, he don't want to divide the whole packet or whole datagram into number of fragments. And if the df value is going to be set 1 and that is true, then when the router will see that df value is equal to 1, that is don't it is the user has set the value don't fragment true, that means he is not going router is not going to uh, fragment this particular datagram. Okay, uh, इसको आप ऐसे समझ लीजिए, मान लीजिए दिस इज द नेटवर्क एंड वन डेटाग्राम इज बीइंग सेंट and the df value is set equal to 1. So when this packet or when this datagram reaches to this router, when the value of do not fragment value is equal to 1, he will see. So he is not going to fragment uh, this particular datagram. Okay, मान लीजिए कि इस नेटवर्क का MTU आपका कुछ लेट्स से 1000 है और देर इज अदर नेटवर्क जिसका MTU आपका लेट्स से 100 है. सो यहाँ पे just because maximum transmittable unit in this network is 1000, that means it may have the larger packet size or larger datagram size, and to send into the network of MTU is equal to 100, router need to fragment this packet. Okay, but as because the user had set the data df value is equal to 1, that means he has explicitly said that do not fragment this packet. In that case, what router is going to do, router is going to discard this packet and will send an error message. Okay, or that would be icmp error packet to the source. Okay, and the source will get to know that router has discarded the packet because of the because the further network where the packet is going to be sent is having lower MTU and my packet size is larger. But as because the user has sent the df user has set the value df is equal to 1, and router is not going to fragment this, and hence this error message is being received. Now what once the router will discard this packet, अभी source खुद ही इस पैकेट को अपने आप में थोड़ा छोटा करके भेजेगा और उसको थोड़ा डिवाइड करके भेजेगा, and then again it will send it to the router, and if it matches with the size of the next network MTU, then router is going to send it to the network. Otherwise again it will going to send an error message and discard the packet. So this is something when a user want either a packet should be sent as a whole, okay, or do not send it. Okay, So if this kind of setting a user want, then he will set the value df is equal to 1. Okay, but if df value is equal to 0, that means the router is allowed to fragment the packet or fragment the datagram, and in that case the router will further fragment this packet and will send those fragments into the next network. So this is what the field df field is. The next field in the second row is your fragment offset. So fragment offset is basically tells you about the number of data bytes ahead of this fragment in this particular datagram. So for example, let's say we have a datagram, and after fragmentation, it is being divided into, let's say, three parts, और you can say three fragments में उसको divide किया है. Let's say this is the first fragment, this is the second fragment, and this is the third fragment. So let's say we talk about this third fragment. यहाँ पे आपका जो offset value है वो ये बताएगा कि उससे पहले कितना डेटा नेटवर्क में सेंड कर चुका है इस डेटाग्राम का. सो दैट मीन्स दिस इज द डेटा पार्ट, this is the data part. So it will add up these the data this of the first fragment and the second fragment, that is actually ahead of this third fragment. Okay, so this fragment offset will tell you how many data bytes ahead of this particular fragment. Okay, so similarly if we talk about the second fragment, then we will say the fragment offset value will tell about how much data is ahead of this particular fragment. Okay, so this is something what the fragment offset is. Now we will talk about the fragment offset also in detail when we are going to discuss the fragmentation. So we will talk about the next field or next row. Okay, there is one thing that you must note over here, that this second row is purely dedicated for the fragmentation, because you have seen the identification number, don't fragment, more fragment, and fragment offset field. So ये सारे field आपके किससे related है? Fragmentation से related है. Okay, and hence this IP header की जो second row है वो आपकी majorly फ्रेगमेंटेशन को डेडिकेट की गई है.